Often perceived solely as destructive forces, forest fires play a crucial role in the cycle of renewal and balance within ecosystems across the globe. Forest fires are a natural phenomenon that has shaped the landscape of our planet for millions of years. They occur when combustible vegetation, influenced by factors such as lightning, volcanic activity, or occasionally human actions, ignites, leading to a rapid, intense burning of forested areas. But beyond their immediate fiery fury, forest fires are instrumental in the ecological process of renewal and balance. One of the key functions of forest fires is their ability to clear out dense underbrush and dead materials that accumulate on the forest floor over time. This clearing process reduces competition for nutrients among surviving plants and trees, thereby increasing their health and vitality. Moreover, the removal of thick underbrush enhances sunlight penetration to the forest floor, encouraging the growth of a diverse range of plant species. Forest fires also play a vital role in the life cycles of many plant species. Certain trees, like the serotinous cone pine trees, require the heat from fires to open their cones and disperse seeds, a process known as serotiny. This heat-triggered seed release ensures the regeneration of forests, with new growth emerging from the ashes of the old. Furthermore, the ash left behind by forest fires enriches the soil with vital nutrients, promoting the growth of new vegetation. This nutrient-rich environment fosters a resurgence of plant and animal biodiversity, making post-fire ecosystems vibrant with life. While forest fires can have devastating immediate effects, especially when they impact human lives and property, their role in natural ecological cycles is undeniable. They act as critical regulators, maintaining the health of forests and ensuring the continuation of diverse ecosystems. While forest fires can be beneficial, the risk of uncontrolled wildfires has increased dramatically, fueled by human expansion and decades of fire suppression policies. These factors have led to overgrown forests with dense underbrush and accumulated deadwood, creating prime conditions for catastrophic fires. This is where forest management becomes crucial. Effective forest management involves a combination of techniques designed to reduce the risk of uncontrolled wildfires while preserving the ecological benefits of fire. One key practice is the removal of excess underbrush and deadwood, often referred to as fuel reduction. This can be done through mechanical means, such as thinning and pruning, or through the use of controlled burns, also known as prescribed fires. Prescribed burns are carefully planned and executed by experts under specific weather conditions to mimic the natural fire cycle. These burns reduce excessive fuel, promote the growth of fire-resistant plant species, and maintain the health and diversity of the ecosystem. Additionally, strategic fire breaks, clear areas that act as barriers to slow or stop the spread of fire, are employed to protect residential areas and critical habitats. Forest management is not just about preventing wildfires, it's about working with the natural cycle of fire to ensure the long-term health and resilience of forest ecosystems. By incorporating scientific understanding and traditional knowledge, we can strike a balance between the regenerative power of fire and the need to protect human lives and property. Fire, humanity's primordial ally, has been at the heart of survival, innovation, and the advancement of civilizations. Its journey with us begins with the campfire, our first foray into harnessing nature's elements. The campfire did more than ward off the darkness and cold. It transformed diet and nutrition, allowing early humans to cook food. Cooking not only made food safer to eat but also more digestible, unlocking calories and nutrients previously inaccessible in raw foods. This nutritional revolution bolstered brain development and social cohesion as communities gathered around the fire, sharing stories and knowledge. The evolution of fire's use finds a remarkable chapter in blacksmithing. This ancient profession, dating back to at least 2500 BC, saw artisans wielding the elemental power of fire to forge tools, weapons, and architectural marvels. The blacksmith's forge, a furnace capable of reaching temperatures over 1000 degrees, allowed for the manipulation of metal, bending it to humanity's will. The innovation of smelting iron, a practice that began around 1200 BC, revolutionized societies by providing stronger materials for agriculture, warfare, and construction. Advancing into the domain of metallurgy, fire's role expands into the extraction, refining, and alloying of metals. Metallurgy has been instrumental in human progress, enabling the Industrial Revolution and modern technological advancements. The development of steel, an alloy of iron and carbon, was a turning point. The Bessemer process, introduced in the 1850s, utilized a blast of air through molten iron to reduce carbon content, producing steel efficiently. This innovation paved the way for skyscrapers, railways, and bridges, literally shaping the modern world's infrastructure. Moreover, the controlled use of fire in metallurgy has led to the creation of specialized materials crucial for contemporary technology, including the aluminum for aircraft, titanium for spacecraft, and silicon for electronics. Each of these advancements underscores fire's indispensable role in driving the technological and industrial achievements that define our current era. From the communal warmth of ancient campfires to the complex processes of modern metallurgy, fire has been a constant companion in humanity's quest for growth and understanding. Its mastery has not only provided the means for survival, but has propelled us into a future filled with unimaginable possibilities, cementing fire's legacy as a true catalyst of civilization and technological marvels.